You can hear me fine? Oh, there we go. Thank you. So the introduction, Joni Mitchell's song, and I think it was really fitting since the topic is cloud computing, but not necessarily perfect cloud computing. I'm also going to talk about something that went wrong, what not to do. I'm going to go through some cases where I've been working on for the last couple of years, and look at this is something you could do, this is something you should do, and this is what we did. So I've failed, I made mistakes. Hopefully you all do. No, I assume you're all a lot better, so you never make mistakes, right? But I'm going to make this a little bit challenging for the guy with the mic here, because I want to try and make it an interactive session, because I know what I'm talking about. But you might have questions. So please stop me anytime during the presentation, ask questions. I'll try and make this a dialogue. So if you have anything that you're wondering about, please feel free to ask. I'll try and repeat the questions so you can hear it on the recordings afterwards. So, perfect. This is me. I work over there. But this talk is not about me, and I am pretty sure you didn't come here to listen about my life story. So instead, I'm going to talk about cloud computing, cover some big data, some IoT, or both of them together in an architecture type session on actual cases. One of the cases I'm going to talk about is really slow TV. Got some ships that has been traveling up in the Botniska Viken. Sorry, I don't know how to pronounce that in English. Where we had the two ships in the icebreakers with 15 cameras, a bunch of sensors and stuff. So if you want to watch 15 cameras times 2 boats at 60 images a second, that's slow TV for you. But, so. I want to make this interactive. Hands up, who knows what this is? Nobody? Oh, I've asked this question a couple of times, and usually, but I was expecting a lot more hands up, given the audience, given this conference. Anybody want to make a wild guess? Shout it out. Oh, lovely. That is correct. Open source GitHub or open source contributions on GitHub. And the cool thing, on top of that list is Microsoft. And this was before we bought it. So some of you might have heard the news that Microsoft bought GitHub. This is not the reason. But the reason, I think, and this is my personal opinion, and also what I think typically we do when we do these kind of acquisitions is that we really want to integrate with them. Open source is so important in Microsoft now that we need to be where the developers are, and they are on GitHub, and they are using open source. So, and I think it's really interesting to see that we are on the top of this list. So we're actually the company that contributes most to open source, if you consider GitHub to be the benchmark for that. And that is quite different from what Microsoft used to be. So I used to work in Microsoft for a couple in and out, but for about 12, 14 years ago, I remember writing an article about the evil of Linux. And Steve Ballmer at that time, he called it a virus. So transferring from that into this, that is, that's quite a change for a company. And I'm sure we're not the only company going through that kind of a change. I'm sure there's a lot of other companies that's starting to embrace open source, and including either open source components or end-to-end open source solutions in their application portfolios. This is something you need to. So who's using open source? Yeah, got a light in my eyes, but I'm expecting everyone. Exactly. So this is something I don't expect you to know, given the audience. So this is, who knows what S&P 500 is? Wow. Okay, so there were actually more people who knows what that is, but not GitHub, or the GitHub contributions. Oh, surprised. Okay, I have to admit, I had to look it up. I had to Google, Bing it. So yeah, you use the tool that's best for the job, right? I get that. So S&P 500, that's an index for the most, let's call them the most important 500 companies. So it's not necessarily just the biggest 500 companies worldwide, that is, but in different industries, it's the most important companies. Let's call them that. So it's a pretty important index, and we can call it a benchmark for what companies in general do. So 100 years ago, on your left-hand side there, that's 100 years ago. Typical company 100 years ago would last for 67 years. So you were around for a long time. Changes didn't happen that fast. Okay, you can expect that, okay, I start a company, I do something, and you can continue to do exactly that for quite a long time. But over the years, this has changed a lot. So we are about, or the survey's a couple of years old, but we are about here. So those companies in that index last for about 15 years. And a couple of years ahead, only 25% of the existing companies in that index will exist. So 75% of those companies will cease to exist. They won't be on that list. There will be new companies. That means that companies need to adopt change. They need to be able to understand, okay, what is important now, and what do I have to do as a company to be able to even exist in such a short-term or near future. So they need to be able to do something differently. Okay, so I'm going to make sure that if you fall asleep during the presentation, if you think it's boring, you want to check your cell phone, do emails, stuff like that, you need to watch these, because I got 3 of these, and that's the highlights of the entire speech. So as long as you get these 3 slides, and maybe I should have this pling sound, and you can read those. But okay, so if you get this, that's the highlight of the presentation. So far, I've said that open source is cool. Yes, do embrace open source. And it's change or die. And I truly mean that. Companies need to be able to change, and you need to be able to do that fast. So, IoT, Internet of Things. I assume everybody knew that. There's no, or at least I haven't seen, a single definition for IoT, or it's not a single, there's lots of different definitions for IoT. And for those of you who have been following the different IoT talks during yesterday and Wednesday, have probably heard a lot of different versions. There are talking about industrial IoT, there's talking about the commercial IoT, there's lots of different ways of using IoT, and the IoT has been one of the buzzwords together with digitalization, and I'll try not to overuse too many of them. But basically, it is a lot of stuff, a lot of things that you want some kind of insight into, and based on that insight, you want to do some actions. And hopefully, you want to automate that action. And that's actually probably the most difficult one, is the last one. And I've seen that a lot. People tend to trust their gut feeling. I've been doing this for 20 years. I know exactly how this works. So you can give me any sensor, any indicator showing something, but I know this best, right? So the typical scenario I see a lot is that, and especially in industrial IT, they already have a lot of sensors. So they have the things. They're already there. But they're typically just showing some kind of a gauge, maybe a temperature sensor. Maybe you even have a red light saying, oh, something's wrong, blink, blink, blink. But then you want to have a human that does something, right? You want to have a human that's turning the temperature down. Somebody does that. Because a human never does any errors, right? We always do things right. We're the best one to turn down the temperature. There's no, I don't see, of course, there are reasons, but that's typical thing you could automate. So that's my goal, is to try and make that end-to-end. Try and persuade people to, hey, you can actually automate this and trust the machine. Yes. So hopefully we'll get there. Okay, so promised you a lot of IT cases, or IT/big data/cloud type of cases. I can't talk about all of these, and I don't know about all of these either. Like dogs, I have no clue why dogs are in there. And the whole graph of this, I didn't make this slide, so apologize for that. How dogs links to power plant. If you have a suggestion, feel free to to jump in. Security, yes, that's a good one. The closest one I got was that you need somebody, since the whole plant is automated, you need somebody to keep you company. So that was the dog. Yeah, something like that. Connected cow, that's an interesting one. Where they're actually monitoring the cows to see when they are fertile, to to make cow babies. We have some public references on aircrafts, on Rolls-Royce engines, where they are monitoring the engines to reduce fuel consumption, to look for maintenance needs, to try and ease the logistics of it, because they try to make the part available as soon as the plane lands, so the plane can run for longer periods of time. So that's an interesting one. But I'll stick to the Norwegian ones. So power plants or smart grids. We have a company in Norway called Agder Energy. I've been working with these guys to create a smart grid, because they have a lot of these trafo boxes. Sorry, I can't come up with the English name of those. It's the relay of the energy. And these boxes, they have to be built to manage the maximum load any given time. Because the opposite, if it doesn't, somebody doesn't have power. And imagine that. You can't, hey, I can't turn on a light, I can't cook, I can't do something. So everybody has to have power at all the time. And when it's typically the max load, it's when it's really cold, you're home, cooking dinner, so that's perhaps Christmas Eve, right? Something like that. It's Christmas Eve at 7 o'clock. That's the peak load, happens once a year. And you have to build those boxes for that load. And these boxes, they're not cheap, right? So the whole project was, how can we distribute this energy? How can we combine solar, wind power, together with turbines, together with all kinds of other, and batteries. We have these huge Tesla and BMW batteries. How can we use all those distributed to reduce that peak load? Really interesting. Another one that's not Norwegian is the elevators over there. ThyssenKrupp, they're also doing some predictive maintenance on their elevators. And the interesting part with that is actually changed the whole model of how they were running their company. Because instead of selling an elevator and sending a technician and charged by the hour, they were selling elevator uptime. They were selling that, hey, I guarantee that this elevator works 99 point, perhaps it wasn't 99, but I guarantee that this elevator works this kind of percentage. So they give an SLA on elevators. And they could do that because they had a lot of sensors. They had all the information about the elevators, how they were running, predicting when it was going to fail, and make sure that they'd fix the part before it actually failed. It also reduced the number of technicians they needed because they could send the technician in the right order to the right elevator at the right time. Really cool. More Norwegian ones. And some of the ones I'm going to talk more about is within oil. Oil and gas, that's the industry I've been working in the last couple of years. So I'm still a oil newbie, but I'm learning. And that stopped working. Ta-da! This company. This, I know I wrote in the introduction, I wrote that it's a large oil company in Norway. We don't have a lot of large oil companies in Norway, but it's not a public reference, so that's how I have to write it. And I have to admit, I stole this slide from them, so it's their own slide. This is their scenario, right? This is how they make money. This is what they do. This is their core business. First, they have to start by exploring. They have to find the oil. And keep in mind, this is from not an oil person. I'm a developer. I got some architect in the title, but yeah, I'm not in oil. So keep that in mind. But they start with exploration. They have to find this oil. They have to find where it is, and they have to find where they can drill. So that's what these guys are really good at. They're really good at drilling holes in the ground. So that's the next phase, is that they make these holes. Sometimes they hit, sometimes they miss. And then I'm surprised it's really, really deep. And these drills, they can move all around. So that's impressive stuff. That's really impressive engineering doing that. And then I need to get it up. And they probably need to transfer it somewhere, process it somewhere, and then sell it. That's typically where they stop. There are other downstream oil type companies that does the rest of it, but this is typically where they stop. But all these different phases are organized in silos. Individual ones. Like the guy who owns the oil platform, he's and then in this industry, that's the king. That's the guy. His number one job is to make sure that his platform is operational and working and pumping oil or gas. That's his number one. So he's a silo. And then the exploration guys, those are a silo. So those are separate guys. They do their stuff. And nobody understands the math in that, so leave those guys alone. And then you have the transportation, the logistics of it. That's an entirely different business altogether, so that's a silo. And you have all these. And then this company, I'm finding it hard not to name them, but they found that, hey, we need to change. We need to do stuff. We need to do more digital stuff. And it's also interesting to see how different parts of the organization think about digitalization, what they actually think digitalization is. From top management saying, like, yes, somebody told me digitalization is important. That's what we're going to do. We're going to digitalize. And what is that? But okay, they needed to digitalize. They needed to gather data to do analytics, for instance. So Mr. Data Scientist came along and said to the exploration guys, hey, can I get some of your data? I promise I can improve your results. And they said, nah, maybe not. Why would you have access to my data? My data is really special. You probably don't even understand it. But okay. So after some talking, some escalation, some manager talked to manager, he finally got that data. But that's just the start. Because this data scientist, he couldn't just use exploration. He needed several of these silos. He needed access to more of data. So he had to go to the next guy, say, look at his hat, hey, I'm Mr. Data Scientist. Can I please have your data? And then all over again. No, this is really special. If you want access to this data, you need to be on the insider trading list. You need to have proper security clearance. You need to blah, 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 all that. So, and then same thing over again, escalation, blah, blah, blah. And doing this over and over and over and over and over again is, as you probably understand, time-consuming. And that was just the politics about it. And then all of these different silos, of course, they had different data formats. So maybe these guys had some kind of a proprietary file format, and then somebody had some CSVs, somebody had some parquets with an entirely different structure altogether. Nothing were aligned. So we had a lot of challenges to combining data from all these different data sources. So somebody came up with a brilliant idea. OK, let's put this together. Let's create a data platform to orchestrate data. Good what? Good option. So, same time, they hired some, I don't know the consultant company, but some consultant company, some McKinsey's, BCG's type of company. On their, as I mentioned, they decided that, OK, we need to digitalize. So they came up with these 6 points for their digital roadmap. See, I even managed to put in the black there to hide over, because it's actually their slide. So they came up with these. I'm not going to go through the different the different points of their digital strategy, but the important one is they figured out that, hey, all of these are actually related to data. All of these has something to do with data in one way or the other. So this data platform became more and more important. And they saw that how this data platform was relevant for their digitalization strategy. OK, so let's start to use this data platform. We want to do some projects. And yeah, so please, any questions? Just go ahead. You're too scared. I'm doing all the talking. OK. One of the first projects was in the US. It was on their onshore operation. So onshore operation is slightly different from the Norwegian continental shelf. It's not my architecture slide, but the US onshore is slightly different. They have a lot of different, call them units, that drill holes, right? So it looks like Swiss cheese in the end, like this. Holes all over. And you have these guys who drive around, adjust some valves, drive to the next one, does some adjustments, and then drives off. Had an interesting, it was the wrong way to say it, because some of these are so far off that one of these guys driving around, he actually ran out of fuel in the middle of nowhere. No cell phone coverage, nothing. So the guy almost died, actually, before he got back. But yes, so we started with all these devices, or all these units, we started collecting data from them. Or they had the sensors already in place, so we started collecting data from them, transferring that data in batch to the cloud. And then to do some, the plan was to do some processing, we're going to do some advanced analytics on that, and so on. But currently, it's mostly for monitoring. We also started working with these guys. When you had that guy who drove off and almost died, we said, OK, it's important. We need to monitor the drivers as well. So they put GPS on the cars. and we're tracking where they were. And it was, of course, a security measurement to make sure that the drivers are safe. An advantage, they could also optimize the route for that driver. So they know where every driver is, and they can optimize, so he should go there, before there, before there. But an interesting fun fact as well, they don't have GDPR and stuff like that. So it's slightly different how to handle personal data. But they discovered, how do you think these drivers spend their time? Any guess? Guess? What if there was a pub nearby? And those kind of things show up when you start collecting data of where everybody is driving, right? So some of these drivers, not all of them, of course, not in general, but some of them tended to spend a lot of time on the pub on the way to whatever maintenance job they were going to do. So that was really, but the whole project was a really success. They were able to collect data, transfer data, create some dashboards, do some analytics, do some data processing, and visualize that. So it was a huge success. So, important thing, before I go to the next. This operation was rather small in combination with the Norwegian continental shelf. So, this guy came up. And now the whole point of not telling you which company it was goes away. It's a really good point. And also about how, I shouldn't mock him, but what they think about digitalization. So what he refers to as Pokemon technology is in fact HoloLens. And the guys have a stand down here, and I really recommend you go down, look at it, because what they've done with Pokemon technology is absolutely brilliant. It is really top of the line worldwide what they've managed to do with HoloLens. It's really impressive, I must say. So go down. I recommend go down there, try them out, see what they've done with their 3D models of different plants, and how they can track and how they can actually control the different pipelines and valves and stuff in using HoloLens. So that's interesting. But he didn't just talk about this is how media does it, but he didn't just talk about Pokemon. He also talked about another project that we started. So we took the concept of what we did in the US, and the plan is to apply the same thing on the Norwegian continental shelf. So going to do, it was a huge success, so let's do exactly the same thing in Norway. And then the Norwegian operation is a lot larger than the US one, like several hundred times larger. After just a kickoff, we hadn't really done a lot, or yeah, I assume there are some people here from the, oh, I see some. So we hadn't really done a lot, but we've started the project. And then she came along. Oh, we got this Supercenter, and it's going to be located in Bergen. Okay, there's no data in Bergen. There's no, given that the cloud isn't in Bergen, the cloud is a different, yeah, never mind. But okay, so it's already a success. We haven't done a lot yet. And we tried to do exactly the same as we did in small scale, in large scale. So they had the architecture was pretty easy. There was some virtual machines and a SQL server or a SQL data warehouse and a Power BI dashboard. But if you try to do exactly the same thing and multiply it by hundreds, you are set up for failure. So the project is still a success, but we found out that we have to do things differently. We can't, okay, we are using the cloud. Yes, we were using the clouds in both cases, but we have to do things differently. So this is what we did. This is more of a, in general, not the specific architecture design, but it's the high level of how the setup is, or yeah, actually is. So we need to have two different ways of ingesting data. We need to, I'll be happy to share the slides, you know, since I say a lot of people wanted to take pictures. be happy to do that. We need to have two ways of ingesting data. We need to ingest data both as batch. We had that 15-minute interval you remember I talked about, which really isn't all that impressive. We also had to run that in real time. So we needed data more up to date than those 15-minute batches. Okay, so that's a requirement. We had a lot more data to store, and although SQL servers are great, and we're working on those huge terabyte-size SQL servers, okay, but maybe not for select star type queries where you want to do analytics across hundreds and hundreds of terabytes of data, right? We're even talking petabytes eventually. So we needed somewhere to store data. So that's where we started with this architecture based on best practice. Or we have stopped using best practice because there is not really such a thing as a single best practice anymore. So we have a lot of good practices now. Instead, and you can see the same thing from this slide. Because a lot of these components do the same thing, or slightly different but similar things. And that's also really interesting when you think about cloud computing, since there are so many components doing so similar things, and you don't have to buy hardware, install stuff, you don't have to have all that, the whole process. So it's a lot easier to just, okay, let's test this. Okay, try it for a couple of hours, didn't work, try something else. That process is a lot easier. You can just delete, start over. I did it wrong, I failed. Okay, never mind, delete, start over. You can do that multiple times. So you can test, does this work in my scenario? So we've done that. How familiar are people with Azure? Anybody created anything in Azure? Ooh, cool. So many. Nice. I love it. OK, so you are fairly familiar with these icons. I'm not going to go through every one of them in detail. First one handles data ingest, the first set. The top one, Data Factory, is the batch processing. Also the whole data pipeline orchestrator. So that's the Data Factory. And then below that are the different event hubs. We are actually using both event hubs and the one called IoT hub, but call them event hubs, both of them, together with a Kafka cluster. That Kafka cluster is running on HD Insight. So yes, different service for different needs. And then we need to store the data. The primary component for storing data, in this case, is the data lake store. So somebody in marketing was brilliant enough to take the concept of a data lake and call the product exactly the same thing. Makes it easy to, yeah, I'm going to create a data lake. Oh, there's something called data lake. OK, go. Provision. Done. Yeah, but it's a large file store specifically made for analytics. That's the basic of it. But it doesn't solve everything. Currently, it's not so easy to share data from the data lake if you want to share it externally. So we're using Blob for that. There's a lot more tools that work with Blob than with the data lake store. You have to have authentication mechanisms and so on. So we use Blob, for instance, for sharing data. I'm going to have an interesting use case on that a little while. And then you need to process this data. And there's a lot of different people. I talked about the data scientist guy. He was either writing Python code or R code, or somebody was writing Scala. There's a lot of different people working with this data. So we had to offer different tools to support all of them. So the data scientist guys, they chose all this themselves. I didn't mix up we as Microsoft or this old company. But yes, they chose a set of tools. So they chose Databricks for the data scientists, and in Databricks. Databricks, for those who are familiar with Databricks, the guys from academic environments who came up with Spark in the first place, they started their own company. It's really a smart thing. You start a product, open source, and make sure it's adopted by everyone. It is the the #1 tool to use for analytics. It's no doubt. And then they started a company, made the product about 20–30% better, more optimized, but you have to buy it, right? So but it's really good. So if you are using Spark, I definitely recommend you look into Databricks. It's better performant and easier to use. So they chose that tool for analytics, but for data engineering, they have a different set of tools. So some of them are using Databricks there. Some of them are using functions, Azure Functions. Some of them are using Data Lake Analytics, as you see up here. There's a lot of different tooling for different use cases. Another interesting one I want to point out, and it's not really in the current architecture, is the one as under Stream Analytics. I just added it in without the logo. It's called TCI, or Time Series Insights. Since a lot of this data, a lot of this sensor data, it's time series. And time series, it's a lot of them. It's really simple. It's usually just some kind of an ID, a tag in this case, a value, some kind of a number, and a timestamp. That's basically it. So the whole schema is there's not a lot of, there's not an advanced schema, but it's a lot of these time series. Time Series Insights is a great tool for handling those, both for creating visualizations, do all that time series specific handling, zooming in, zooming out of data, slicing, dicing, that kind of stuff. So great tool. It's not part of their actual architecture as of now. It's because it's quite a new tool. And then they need to have some kind of structure on some of this data, not all of it, because all kinds of visualization tools in the end, whether it's their custom application, whether it's a Power BI, Tableau, Click, something like that. They use Spotify a lot. So some of those, most of those, they like to have it structured. They like to have a known schema with known data types and so on. So we use the either Cosmos DB, which is a NoSQL database, or we use the SQL Data Warehouse or SQL databases to create those kind of structures. So this is an example architecture of how to build a data platform. Cool. Giving you some time to, if you want to ask questions. So one advantage with having this data platform and having it in the cloud is that it's so easy to share data. And this is actually from yesterday or the day before yesterday. So I just managed to. So they also started embracing open, not necessarily open source, but also open data. So, and this is at least the first time I know about that they've shared an entire data set for exploration, for drilling, for the whole telemetry. The data set is huge, and they're sharing it with everyone. So everyone who wants to try and, okay, I'm better at this and then this company at finding oil or gas, you can download this data set and work on it on your own. So I think it's a really interesting way of looking at how this industry is moving, that they're actually sharing data with others, with their competitors, and so on. Because one of the biggest challenges I see in this industry is that a lot of the suppliers and a lot of their vendors are saying that, hey, it's my data. I'll share the analytics with you. You have to buy it, of course. So you have to pay a little bit extra, and I'll give you the analytics. But when you have a lot of these suppliers, like a platform has some components from Siemens. They have some components from ABB. They have something from Kongsberg. They have some for Schlumberger. Schlumberger is down here today. And all of these guys say, hey, yeah, sure, bring the data to me. I'll give you analytics, no problem. But I'm not giving it to Siemens. I'm not giving my data to ABB. I'm not, yeah. So they need to have a way of collect this data because they need to do work processing across all the different vendors. Interesting to see that starting to move. need to be more, more sharing. But data platforms, it's not just a company I talked about, but a lot of different companies. And one great thing when you use cloud is the scalability. Yes, you have to do things differently. You can't just have the same architecture that you have on a small scale and large scale. Yes, in many cases you can actually. And that's interesting because 3 of these guys are pretty large companies. But then you have this guy. For those of you who don't know him, this is Captain's, what do you call it, Sabertooth? Is it called that? Sabeltann. He's at Dyreparken i Kristiansand, which is a Norwegian zoo. And they have a data platform. And the fun thing about that data platform is almost the same as these others. Even though they hardly have an IT department, it's a couple of guys. And that's why they can use the same components. They can use all the same services that I showed on the previous slide, just in a small scale. So they can use the same thing as a huge oil and gas company. And of course, they just pay for what they use. Which is, I think, really interesting. I actually used this, when I created this platform, I used it to learn a lot because you can fail, test, do stuff in small scale before you scale up. Okay, wake up, bling! Key takeaway from my babbling. Start do things differently. It's important. The sub under there is actually from my mentor in Microsoft. I'm not naming because this is what he said when they asked him. Okay, how should we do this? How are we going to approach our digitalization strategy? And he came up, yeah, you have to shoot all your architects. And I'm kind of scared because there is an architect in my title as well, so I was a bit afraid. But his point is that you can't take what you do on-prem and do the same thing in cloud. It doesn't work. You don't want to do that. You want to use the cloud capabilities. You want to use the PaaS services, the SaaS services. You don't want to have a set of VMs and install everything on them. Yes, I totally understand you have to do that in a lot of cases. And you have a lot of applications that's just how they work. But maybe you can create containers. Maybe you can make that work for your application. So and use some kind of a managed container service. And there's a lot of capabilities using cloud, but you have to do things differently. So, okay, perhaps not shoot the architects, but make sure they understand that they need to do things differently when they work with the cloud. So, how am I on timing? Oh, okay, I got some minutes left. What are we going to do next? And this is the stuff that we haven't done. This is the stuff we're talking about, and what we are hopefully going to do. So we not necessarily we in Microsoft, but we with this on a company. So we in Microsoft, we are trying to make it easier to use IoT. We have something called IoT Central, which is not something the oil and gas company is using, but it's for smaller, mid-sized companies that just starting with IoT. Perhaps you don't have a full IT department. You want to simplify it. You don't, and this is the wrong audience to tell this, you don't necessarily have to write code. But it's a lot closer to something called plug and play. It's a SaaS service, software as a service. And then we have the IoT suite, something in between. There are some pre-made solutions that may or may not fit your exact need, but all that you can configure. You can rewrite the whole code. It's all there. It's all available to you. It's just examples of how you can do it, how you connect the different services, how you set up the type of platform I showed. All that is in a pre-made solution that you can reconfigure, rewrite to your own needs. So it's a great way to get started. If you want to test something, see, and you know that this is a really specific case, it's a great way to start. Start with some of these pre-configured solutions. You get an interface, you get all the components, you get them connected, all that stuff. Okay, next, what we are going to do is we're going to start using Edge. Edge is, I think this is super interesting way of looking at IoT. So when there are different things you can do on Edge and in the cloud. Who are familiar with the Edge concept? Not in a Microsoft concept, but okay, some. Okay, good. So in the cloud, you have the huge capabilities. You have the huge scalabilities. You can have multiple servers, hundreds or thousands of servers in minutes or seconds. But there's a lot of stuff you want to do on the edge. And there's a lot of reasons why you want to do stuff on the edge. Maybe it's as simple as, hey, I'm transferring data over a satellite. There's not a high bandwidth over that satellite. So I need to reduce the amount of data I'm transferring to the cloud. Oh, Edge could be a good example for that. Could also be stuff you want to do some filtering, you want to do some initial analytics, and you can do that on the edge. There's a lot of different reasons why you want to do things closer to the device. Just a simple thing as we're still dependent on the speed of light. So we have to transfer data from the device to the cloud to do something. And there's such a thing as quantum entanglement. And I know, how are you in mathematics? Okay, we still rely on the speed of light. It takes some time to transfer the data, and the cloud is somewhere else. So we have the edge concept. The IoT Hub, I mentioned the Event Hub's IoT Hub, similar thing. And then you have your solution. All this exists in the cloud. And then you have your IoT device. The IoT device could either connect directly to the IoT Hub, or you can use an edge device. Might be such a scenario where your device is talking a specific proprietary protocol. We are supporting set of protocols, and Anders was talking about that yesterday, together with security, how to handle that. But you might want to do protocol conversion using edge units. So there's a lot of different reasons why you want to use edge. Here's a little bit more technical details about the edge. So edge consists of a set of modules. Each of these has their own container. You can take some of the Azure services and deploy them on the edge. So you can take, so let's say I have an edge device. I put it on my platform, and in that edge, in one of those modules, I can put a stream analytics service. So I can, every time I get something, some data into that, I can filter that data and say that, hey, I'm only going to transfer what is relevant and transfer that data to the cloud. Maybe I want to do some monitoring. Maybe I want to add some alerts. Hey, I have this threshold and it's going above. I don't want to wait for transferring the data to the cloud and then back again to get that alert. It might be critical that I get it now. It's a lot of different modules, and we're adding more all the time. You can also create your own custom module, so anything you can put in a container, you can put on the edge. And this, of course, the edge is a piece of hardware, so it has to fit within the boundaries of that hardware. We're not developing hardware, so it all depends on what kind of hardware you are using for the edge. Here's an example of how this could be done. So this customer, or this is a fake type customer, has a lot of stuff in the cloud, and they have all these sensors or edge devices in their factories. Then I can take all these services and one click too many, and deploy them on edge. So they're running their machine learning, they're running a lot of their analytics on the edge, close to the device. And then what's relevant, they can move to the cloud, they can collect the historical data, they can do the retraining of their analytics models, and so on, and then deploy them back. I even managed to include the time series insights on that. Okay, so bling moment. Do Edge. Absolutely. That's what I wanted to say. You want to? Thank you. Thank you. Okay. So glad so many showed up. Thank you very much for that.